of the Building Functional Web Services with Scala and http4s web series. In the first video, we went over the quick starter skeleton project, going over the project structure, their specifications, how do you define routes, and how you define a domain. In this video, we will start repurposing that to build our own web service. We are going to build a web service to host recipes. In this video, we're going to focus on the construction of the metadata of a recipe. So we won't be tackling things such as like recipe instructions and like concept of ownership. But in this one, we're going to go ahead and get started with the basic idea of being able to create a recipe and retrieve it. We're also going to skip out on the data store, the details of the data store as far as like an actual data store. We're going to emphasize on the construction of the API using an in-memory data store, and then we'll swap that implementation out with a real one in subsequent videos. So let's go ahead and get started. Under the project documentation, you can just follow along with this quick start. So go ahead and just run this command and have that set up the new project. We're going to accept all the defaults. The only thing is we'll give it a name. And so we're going to call it recipe service. Okay, that did not work for some reason. Okay, hold on. Let's try that again. Yeah, I had the existing project there. So we start from scratch. So we'll give the name recipe service as our web service or microservice if you want to call it that. And then accept all the other defaults. And as a minor amendment, in the previous video, I was calling our JSON or serialization deserialization library Circle. It is not Circle, it is Sourcecode. So I'm not sure where that was coming from, but the JSON library we'll be using, or serialization deserialization library, is Sourcecode. And this is basically a Scala equivalent of Jackson, but allows you to approach serialization deserialization with from a more of a functional point of view as opposed to I guess declarative programming through annotations. So so we have this checked out, so let's go ahead and open it. Okay, it looks like it's registered. It is an SPT project, so that is good. And we're going to go ahead and let this go. Okay, so like in the other video, we have our it's a standard project, so we have our source, test, Scala, and then tests, and then we have our production code. And so we're going to be doing TDD. Now, we're not going to be doing it by the books, so we will be defining specifications up front and then doing iterative development to ensure that we have passing tests or passing specs. But also at the same time, some of this would just be kind of exploration and getting features implemented and going back and making sure that we have tests to kind of codify those changes for future developers on the team. So let's go ahead and start repurposing this spec. And the idea would be that we're going to start with making an endpoint to allow us to persist or store our recipes. So let's go ahead and rename this and repurpose this to our recipes spec. And we're going to go ahead and consolidate our tests just to kind of keep it simple. So, and then we're going to go ahead and make a test specifically around creating recipes. So we'll say that our test name or test description is creating or creating recipes. Oh, okay. And so then from there, let's go ahead and then repurpose this value. And we're going to make a helper function that allows us to codify what is needed to actually create a recipe. And by doing that, we can then reuse the code for other specifications or other scenarios. The other thing too, we're going to decouple the act of creating our web server and the act of actually defining a request needed to create a recipe. So let's go ahead and first refactor the name of the value, create recipe. We're going to go ahead and convert this into a function. And then from there, what we'll do is go ahead and define our web server. So val server http4s. And also, I should say that I will be using a cheat sheet for some of the types, and also for some of the implicits that are defined, that are needed for some of the serialization. And we'll be going over that in a bit. So the web server is of this type, HTTP app from the http4s group. We are going to be using IO as our effect type in our tests, but everything is generic here, so whatever we want F to be as a generic type we can use, but for our purposes we'll be using IO. So, and then as far as the server definition, that is going to look like this. Excuse me. And then from there, what we would do is we would then run operations against the server. So we'll say server run, and then we'll rename the variable and repurpose it. But the idea would be that we'd be executing different requests against it. So let's go ahead and get started with. We'll update the signature. So we'll go ahead, and so what I did, the signature for the example code was having it in an IO, but I find that wrapping everything in an IO and then testing it is, and the thing is, it's already, there's an IO within a response within an IO, so like I kind of want to consolidate the number of effects we're testing against, and ultimately too, within the test context, like I think it's a safe assumption to make that some of these operations are going to be unsafe in nature. So we'll go ahead and do that. So now it's just a response IO, and then, okay, so now let's go ahead and then repurpose this existing value, and this is the actual request type, and this is going to be what the arguments needed, and the arguments sent to the server as far as performing like a web request. Like when you go to google.com, you're doing a get on google.com. So we're going to go ahead and repurpose this for our request, which we will be making it a post. So we'll say post recipe. So let's update the state here. So we'll say post, and we're going to do a post on recipes. So looking at the URL as a collection of entities, and specifically recipes. And then from there, in order to, the last part of this will be the method body or the request body, right? We need a payload that would be the parameters needed to build our recipe. So we'll say the method signature should accept one type, which is a recipe, which we're going to define in a bit. Once we have the recipe defined, we're going to pass that as an entity, and kind of like in Apache or with Spring HTTP client, you have this concept of request entities. So we would have a recipe, and the API is as JSON on the case class, and that will allow you to serialize this as a payload for the underlying request. So right now both of these are failing, and we're going to need to also update our test. So let's get the test in a little bit better shape, and then we'll go ahead and define our model. So we'll say that in order to create a recipe, we'll pass in a recipe, and recipe has a single argument for now called name. We'll call it foo, and we're going to define this as a value. So we'll say created recipe response, because that's essentially what is happening here. We're getting back a response with that recipe argument, and then we're going to type that, or explicitly write out the type so we kind of know what we're looking at, and that type will then have a status. And so before it was wrapping, the example code is wrapping it in an IO. Since we're already we have an IO within a response within an IO, we just unwrapped it by executing it in an unsafe context. So now from here we can go ahead and directly assert against the response status, and then from there we can also map over the response IO. Oh, actually we need to define the recipe, so hold on. So let's say val created recipe equals created recipe response as recipe, because we're going to cast, or I do an explicit conversion of the payload, response payload or response body into our recipe. So we're going to type that too, just to go ahead and be explicit here. and then we'll say from the recipe IO, we're going to map over that, and then we are going to use the recipe name and then assert that the name matches our provided name. And for more like production or like real world coding, I would recommend adding a little bit of randomization for some of these metadata values, because at the end of the day, it really doesn't matter, and it makes some of the tests a little bit more robust, as opposed to like constantly reusing values. But for now, we'll just do simple foo. So let's go ahead and define our domain model, and get this stuff not red anymore. So we're going to go ahead and introduce our recipes domain as a object. And then from there, we're going to introduce our recipe model. So we'll define that as a case class with our singular name value. And then IntelliJC is the definition, so now we can import that. So that's looking a little bit better. Now we need to handle some implicit conversions, so we're going to go ahead and define those within our recipe domain, or recipes domain. The case class you can think of as a like a Lombok data class, and I think there's like another annotation you can customize the annotations of Lombok to where you can have like a builder class that you can build but not mutate. And there's also an immutables project in the Java ecosystem that you can use to easily build objects. But Scala, you get this out of the box. I know newer versions of Java have like record types, and this you can kind of think of as a record type. But a recipe out of the box provides the ability to define state, or encapsulate state within some type definition that you can easily create copies of, not directly mutate. And then it provides like default two-string and hash code implementation. Implementation for you based on the arguments or based on the state that you've defined in your recipe, which is very helpful. And so then from there, let's go ahead and define our necessary imports, or implicits. We're going to define those in a companion object. And so you can think of a companion object as a singleton object of a given class. Now the thing is, what's nice is if you define implicits in the companion object and then import the class, case class into your context, you get the implicits for free. And the implicits allow you to the implicits provide the conversion functionality from different types, or allows you to satisfy dependency requirements. So like for our example here, we are going to need to provide an entity decoder, and then we're going to need to provide implicit. Well, this actually is a separate problem. So this is an import that we're missing here, but the implicits will provide an entity decoder for us. So we're going to need a decoder as well as an encoder. And then we're going to need an encoder and decoder for the entity as well. So let's go ahead and start defining these values. And I'll be using a cheat sheet for this. So this is not coming from my memory. This is coming from a cheat sheet. So, and like I said earlier in the video, I will be providing the GitLab link, the link to the GitLab version of this repo in the video description. So we define the decoder for the recipe, and now we're going to define an entity decoder. And it's generic in nature, with this type F here. But the thing is, the F is going to need to be an instance of sync, and sync being a cat effect. So, and I'm not going to talk too much about cat effects, but for this video, the two that we'll be kind of referring to will be IO as a data type, and sync as an effect. IO also being, I guess, the definition of potential effects. And if you have a Scala background, depending on the ecosystem you're working on, you can think of as a Scala feature as an equivalent asynchronous data type, or data type to perform asynchronous operations. So from there, let's go ahead and let's finish defining this. So we'll define the entity decoder. Then before we get too ahead of ourselves, we're going to go ahead and bring in some imports that we need to get this stuff to not be read. So we'll go ahead and import this. I'm looking at the cheat sheets here. And then from there, that's looking a little bit better, right? Okay, and so then from there, we'll define the encoders now. So and a lot of this code I've kind of copied from the HTTP4s documentation on doing JSON serialization, as well as documentation directly from Sourcecode as well. So you can look at the code examples and also check out their documentation, but now you don't have to worry about it. You can just use this as an example. But their documentation has other ways of doing this as well. And also, like, if we wanted to, for example, we can customize like the definition of the like what the mapping of the JSON looks like to a corresponding case class. In Java, that would be like defining a custom deserializer or serializer, and in Go, it would be similar. It'd be similar to Go as well, where you define a custom mapping function, and then that would be used within the JSON library. So let's see if that helps out here. So that one had resolved that missing implicit, and so now what we're going to want to do next is we want to go ahead and bring in some imports that should fix this right here. And those imports will provide enhancements to the case class that allow us to convert it to the required type that's needed here, which is the entity encoder. So then from there, we'll say is we need these two imports here. So import IO, and then we need another import around syntax. And then we need one more where we kind of connect the two here. So Circe and not circle. Okay, that looks a little bit better. So let's kind of recap where we're at right now. That's not used? No. Okay, well, let's recap where we're at right now. So right now we've defined a spec. That spec is testing or defining how the server should respond, or our expectation of how the server should respond given an input request, and then verifying the response code and then the response body. So we can go ahead and run this and see where we're at. We should have other compilation issues since we have been refactoring things here or there, but we can use this feedback to provide guidance to us in terms of where to kind of start chipping at. So let's go ahead and run that. And syntax issue. So let's try that. Okay. And let's see what happened. Okay, so no compilation issues. That's good. But let's see what happens to our spec. So our spec right here, we have an insertion failure on the status comparison. So let's go ahead and add a clue to kind of give us a little bit more context as far as what's happening. So we'll say expected. We'll do some string interpolation. Status okay. Actual, and then we can provide the result value. So let's try this again. Okay, so expected 200, actual 404. So that makes sense because we don't really have an endpoint defined. So let's go ahead and look at our routes. So we have these two routes, a joke route and then our hello world route. So there is no route for our recipes based on what we define in our spec, right? This URI right here. So what we can do is we can go ahead and repurpose our route, one of these routes, to accomplish this. But before we do that, let's go ahead and remove the jokes, no pun intended, from the project, because we don't really have a need for them anymore. So we're going to go ahead and remove the usage of jokes. Again, no pun intended, from the routes, and then we'll remove the domain, the joke domain as well. And let's compile the code, see what happens if we try running and see if we have any other compilation issues. Okay, so yeah, let's go ahead and remove that. We are going to remove the client. We're going to remove hello world stuff, and we're going to repurpose this as we go. But for now, let's just get the code compiling again. Wait a second. Okay, that's better. So then our specification is still failing, and that makes sense because we still haven't changed any implementation. So let's go ahead and start doing that. Given the existing routes that we have defined, we have this one remaining route function for our hello world. So let's go ahead and repurpose that. So we will call this our recipes routes or recipe routes. And right now it's currently matching off of the requests that are provided and then handling either a get on hello and then else no other routes are supported. So let's repurpose this and use this to define our post request, and the post request will be the post on /recipes. So from here we're going to change that get to a post, and then we'll change the path, and then we're going to actually use that case and assign that to state that we will then use to then do other subsequent things on. So we'll go ahead and change this to post recipes. We'll remove that name parameter because we have no need for it at the moment. Let's go ahead and assign the request match. And then from there, what we'll do is we're going to extract the provided recipe payload from the request with this as function. And that as function is just like in the tests, same thing. We're going to need to define and then that entity, I believe entity decoder. Yep, entity decoder. So let's come back here. So then from there, we don't have our underlying logic around handling and persisting, in air quotes, persisting our recipe. But let's go ahead and run our test to see where we're at now, to see if the request is at least acknowledged. Oh yeah, we don't have a need for this hello world. And let's go ahead and update our production code because we don't really need that hello world algorithm, as it's called here, but that hello world code. So we'll go ahead and run this and see if that gets us a little bit further along. And that is needed in a test. Let's update our test. So this is our test server definition. And since we updated the production code, we need to update our test code. And then we will be using IO type for routes. Okay, so that's better. So let's run that. Okay, so with this current specification, our application is functioning as expected, but it's not really doing much. We're passing in some data and then it's essentially returning it. And so let's make our test a little bit more thorough, a little bit more meaningful. We are going to want to, as a part of the contract for our API, we're going to want to have some sort of identifier be returned on creation. If we were using real data store, we could have the data store handle that. Postgres and most ARM DBSs will auto assign an ID on creation, and I think it's like that for other data stores as well. We could also handle that within the service layer. For this video, we will be kind of doing that, but we'll basically be mocking out that state generation for the purposes of the test. But in subsequent videos, we're gonna let the data store handle that ID generation for us. So let's update our specification to kind of codify that. So what we'll say, we're going to do a new assertion, and we're going to map on the IO for the recipe, and we're going to map on the ID that we're going to add to our state, and we're going to check to see that it is defined. So ID was not defined would be the clue if this part fails, and we need to now we do not add an identifier to our model. So what we'll do is we'll go into the recipe and then go ahead and do that. So we're going to make it an option UUID, so we'll use an option monad, so that way we can kind of illustrate, or we can kind of represent both states, whether or not there is some ID or no ID. In Java, this would be expressed through an optional type. In Haskell, this would be represented through maybe. But in Scala, it's option, either some or none. And so we went ahead and added the ID, and then we've updated our test. And so now let's go ahead and default ID to, because by default, the ID won't always be defined if you're trying to create it from the perspective of the consumer, because the consumer will assume as a part of an API contract that the ID is provided automatically. And then here we go, our test is failing because we have a new expectation that isn't yet implemented. There is no ID. So let's go ahead and do that. So let's go ahead and start implementing our data store abstraction. So we're going to go ahead and introduce that here. So we'll say that once we have the recipe, we're going to try creating it. So we'll say created recipe E, where we return an either created recipe or an else, a left case. And either being another monad that's available to the Scala ecosystem. I think Haskell has the same exact construct as well, where you have both a left and a right case that you can do pattern matching on as well. So you might match that the either is an instance of a left, where left being like your negative case, or a right being your positive case. So we'll say we're going to introduce a formal implementation to our recipes domain that allows us to do things with recipes, and one of those things will be creating recipes. And so here it's not defined, so we're going to go ahead and update the signature to define the necessary dependency, which will be our recipe, our recipes domain, and we're going to go ahead and introduce that to our recipes.scala file here by defining it as a trait. Here, and then from there, what should happen in our routes, we should be able to import that now. Oh, trait, that might be why. So let's come back here. Okay, so then recipes still has no information, no method or API for that. So let's go ahead and add that to the definition, or add the definition to our trait. So what we'll say that this will return F either recipe message or recipe, and this is the left and this is the right. So either can either be a left or right, and then we can pattern match on that. So we'll come back to our route, and now that function has been defined. We're going to import recipe here within this context, and we want to have an implementation for it. We're going to get to that, but the next thing we're going to introduce is our left case, and this is really just a case class that's going to be used to store messages or define messages that we want to hand to the consumer when things go wrong, for example. So case class recipe message, and then it's going to have one value, which will be the message, which will be a string. And we'll import that as well. And then from there, we're going to need to then have an implementation that we will use when initializing our routes. And that's used both here and then in our test server definition as well. So let's go ahead and define our implementation. So we will say recipes impl, and that's going to be how we invoke or instantiate or whatever you want to call it our implementation, our recipes implementation. And so we're going to introduce that within this companion object. And so we will say impl f, and this is going to be our data store. So it's going to be f of some type that we don't really care about in this context. Sync, and then we will say that this is a recipes, or return a recipes of f instance. And so what we'll say from there is we were going to go ahead and then define the recipes implementation on invocation. And I think that is missing that. That's a little bit better, okay. And so then from there, we want to go ahead and remove the not undefined defined implementation, and that will then force this implementation actually define the method, because before it had a body, but this is kind of just telling the compiler that we know that there is no implementation, but it will be implemented. But it's essentially functioning as implementation. It's just not defined implementation. Here now that this is a function, essentially just functioning as a definition or signature for expected implementation. Now we have to implement it in our subclass here, or our instance of recipes here. So we will say that our recipes can be created, and so then from here, this is going to be where we refer to the wonderful Alvin Alexander documentation on mutable data structures in Scala, and we will be using his documentation on list buffer. And this is what will be used to store our recipe state. So we're going to go ahead and import this list buffer. We're going to define a value of a recipes list buffer, and then we're going to invoke this method each time someone calls that API to create recipes. And then from there, we are going to then use use this recipe to then return as a write. So from there, so that satisfies the dependency or the contract here. So let's run this and see what happens. Now we are still missing something. We're missing several things. We need to convert that to a write. Sorry. We're missing a couple things. That's one of them. But we are also missing the logic around the identifier. So we need to, and we're going to need to map on this. So the next thing that we'll need to do before handling the identifier is updating the handling of the created recipe. And so we can go ahead and pattern match on this, like I was saying earlier, where we'll say that we'll match on the either, and the either will either be left message or write created recipe. If it's a created recipe, we're going to go ahead and then return created recipe, and then or we'll say there's a bad request and that we just couldn't create the recipe, and then we're going to return the provided message. And then we're going to import that, and that's going to give us access to the implicits. We don't have the implicits defined. Okay, so let's go ahead and do that then. So we'll go back to this, and we're going to go ahead and jump here. And so let's go ahead and define a companion object, and then define our implicit our entity decoder and encoders, because we're going to potentially need that in our specifications as well. So we'll say object recipe message, and then we're going to do a little bit of copy pasta here, where we repurpose these encoder and decoders for recipe messages. So update the type that's being defined, and then we'll update the values, labels. Okay, that looks a little bit better. Let's go back to here. Let's see if that's done anything. Okay, so that's working out. So that's good. And so from here, our response will be a response of type F, which may either be a bad request, being that we couldn't create the recipe, or we get back an OK. Now the thing is, in terms of API design, you may be wondering, hey, well, shouldn't that be created? That's a great question. Well, what does our spec say? And our spec is complaining about our updated implementation. So what we'll do for our implementation, we're going to use the IO as our effect. So that should fix that. And let's go ahead and actually provide some parentheses there to make that's a little bit better. But what does our spec say? So the spec says that when creating a recipe, we're actually expecting an OK. That should probably be created. So let's go ahead and fix that. And then let's go ahead and then use that to drive our implementation or expectation of our implementation here. So let's run our test to see what happens. Now, to illustrate a point, I probably could have kept that as OK, and then we could test that. So let's go and do that. So we'll keep that as OK, and deal with any sort of compilation issues. So let's remove that, and then let's run that, and let's see what happens. I'd expect that failure is first to fail, or potentially fail a little bit quicker. So we have some other things here. So we need to go ahead and then provide our impl to our production route definitions. Let's see what that does. Okay, so then expected to own created actual 200, and that makes sense based on how we've written out the code. So let's fix that. So we'll say that it's going to now return created as a status code. And let's run that, see what happens. Okay, so the next thing we get is that the ID, like I said earlier, a little bit earlier, we still haven't done anything with the identifier. Like, we're not actually assigning it on creation. So let's go ahead and do that. So in our recipe domain, our implementation will formally introduce the assignment of an identifier for recipe. So let's introduce a concept of a created recipe, where we take the recipe that was provided and then we assign an ID to it. So we will do that using the case class default case class provided copy function, or we return a new copy of the provided of the calling case class. So the ID is assigned to an option of a random UUID. We're going to go ahead and use that to store in the recipes list buffer, and then we'll return the created recipe. So let's run our code again and see where our tests are now. Using the feedback, we made the necessary changes, and now let's see if our tests pass. So our test is passed, and so now we have accomplished what we were trying to do with this specification, where we've defined an endpoint that responds to posts against recipes, or a route that responds to posts against the recipes URI, with a message body of a recipe of a serialized recipe object with a name parameter, returning the created recipe as well as an identifier that you can use to then do subsequent things with. So the next thing we want to do is our other endpoint around retrieving recipes. If this was like real world production code, I would probably go ahead and polish this endpoint out and add some negative cases, like for example, add restrictions around the recipe name. Maybe we don't want to have multiple recipes with the same name. Maybe we want to limit the length of the recipe. Maybe we want to check that the recipe name is non-empty, and have tested explicitly verify that. We're gonna skip that in this part of the video and go ahead and add our new endpoint. But what we will do is after that is we're going to iron out some negative cases to test some things out and go from there. So let's go ahead and start defining our new spec. This spec will be around retrieving recipes. So we'll say test retrieving recipes, if I could spell. There we go. And so then what we'll do is, in order to retrieve a recipe, we'll need to create one. Now we could depend on the previous test state. Now, in terms of test design, it's generally frowned on doing that. But that being said, I have seen cases for that, and it kind of depends on the test suite. So like what we could do is have a dependency where we have one recipe that's being created, then we're retrieving it, and then we're updating and deleting it. But then generally speaking, what usually happens, you end up having like a bunch more permutations, and then it starts getting really unwieldy to maintain. So we'll just reuse the helper plumbing test code, and then just make sure that we're dealing with new recipes. So we're going to go ahead and then create a recipe then. So we'll say val created recipe, and we're going to type that to recipe. And so we're going to create a recipe with a new name. We'll call it receiving recipes. We're going to go ahead and then map that to our recipe, and then also we're going to invoke it, so, or run the IO. So now we have our recipe, and then from there we have our recipe ID. So then we can go ahead and use that or define that. So recipe ID is equal to create a recipe ID. And since that's an option, we're going to go ahead and call the get or else function on it, which will return the underlying option value, which is the ID, the UUID, or whatever is provided. And what we're going to do is we're going to provide a failure and tell the user what happened, that the ID was not provided. So we're going to go ahead and type this out. So that is a UUID. Now we can use that to actually get recipe. So let's go ahead and start defining glue code around what it is needed to get a recipe. So we can go ahead and just copy paste this code and kind of repurpose that. So we'll say the function will be called get recipe. It will accept one parameter, which will be the recipe ID, which will be to keep it simple, just a string. And then we are going to use the response, same method return type. In production code, I would actually recommend encapsulating some of the boilerplate verification within these helper functions. That way you're not checking the status each time or assuming that the status is what you expect it to be, unless you want to check it for each test. And then also having it return the transformed entity, or optional, return the entity as an optional. So let's say you want to test that you can get a recipe as a positive case or get a recipe as a negative case. You may or may not return the recipe, and you could easily wrap that in an option. So production code, I would recommend doing something like option recipe, and that way you'd have direct access to the underlying type you're testing against. But for these tests here, we'll just keep it simple, and just do that within the specifications. So in order to get a recipe, we're going to go ahead and update our request value. So we'll say get recipe will be the new name for it, and run that against the server with the defined routes. We're going to, in order to get a recipe, we're going to need to use the get verb against recipes against that ID subpath. We no longer need to provide a payload, since it's, in addition to the fact that we're not going to need one, we can't really provide payloads on gets. So then from there, given the recipe ID, we want to be able to, we want to go ahead and test that. So we're going to go ahead and call that function. And so we'll say resolve recipe response. And we're going to toString on the recipe ID. And that is my cat in the background craving attention. Hey. And so then from here, the recipe response will be the response IO. So we can go and test that status here. So let's copy and paste that code. And we're going to, on retrieval, the status should be OK. And we're going to use that new response. And then from there we can test the state as well. So we would expect that the ID match as well as the name. So we're going to go ahead and then use or define a new value that represents the deserialized recipe returned on a GET request. So we'll say resolve recipe equals resolve recipe response as recipe. And that should be an IO of recipe. And then we'll say that we'll verify that the ID that's provided contains the expected ID here. Okay. And so you see here IO recipe, and then we're mapping over it and then performing operations. And then using these helper assertion methods provided by munit. And so the thing is, I did here before we were checking to see the method is defined based on the option, based on functions provided by the option monad. Now we're using a contains function to see that the option contains the expected recipe ID. So from here, I think we have a spec to find. The spec is that we can do a get on slash recipe ID that should return a recipe object. And then from here, we'd also probably want to define negative cases. So we might want to define a case for handling what happens if the user provides an invalid UUID, or what happens if they provide no UUID, like if they provide an empty UUID, or if they provide a valid UUID but a UID that doesn't actually resolve to a recipe. So we can we'll iron out a few of those scenarios after this one. So let's go ahead and see where we're at with these specs. I'm going to go ahead and run them and see what how our application responds. So our existing spec is still passing, so that's good, but this one is not. So 200 is expected, but we got back a 404, and that makes sense. We don't really have a route defined. So let's go ahead and based on this test feedback, implement it. So we'll add a new case to our match clause here, and we're going to go ahead and match on a get against root recipes, and then recipe ID. And then from there, what we're going to do is just to see if this is to make sure that we're in the right path, we're going to go ahead and then respond with an OK and see what that does. So code compile, that was good. And so, but the thing is here, when we try deserializing, when we tried handling the message body, there's nothing there, and that makes sense because in the route, we're not returning anything. So let's go ahead and actually start, filling out this code. But it looks like we're on the right track. Now the 404 we were getting is gone, and that's because we've added a new case around handling, gets against recipes. So we're going to go ahead and add that identifier parameter or subpath back, and we're going to go ahead and start writing out some code that allows us to retrieve recipes optionally. So we're going to go ahead and do a new for comprehension, where we use our recipes domain, and then we use behavior that we're going to add where we look find recipes. So we'll say resolve recipe, and I'll use an option for now where we return an optional recipe, where it may be that we do a query for a recipe that doesn't exist, and we want to handle that gracefully. But for now, we'll do a option. We're going to call the method find by ID. We pass in that ID, and then we're going to return, based on this value, a response reflective of the two different conditions. So we'll say we want to match on the on this type, and then from there that could either be some ID or some recipe or no recipe. This is usually the code completion is useful, but since we don't really, this isn't defined, IntelliJ doesn't really know how to pattern match on that. But it would look something like, it should look something like this. but again, the type isn't defined, or this method isn't defined, so it's kind of barfing all over the place. So we're going to go ahead and add this behavior. So let's go ahead and go into our recipes trait, and let's go ahead and add this function. So we'll say define by ID, and we're going to say ID as a string, f option recipe. So then we'll go into our impl, and then our impl is going to need to actually implement that behavior now, right? So let's go ahead and do that. And then from there, what we'll do is we will use, we'll go ahead and evaluate this expression where we say recipes, find me a recipe where the ID of the recipe contains this provided identifier. Now the problem is that identifier is a string, so we're going to need to handle this. So let's go ahead and separate that out. And we're going to make a function that transforms the ID from a string into a UUID optionally. So it may be that the ID isn't a UUID, and so we want to handle that through an option. So we'll say resolve ID string, and then that's going to return option UUID. Oop. And then the method signature, or the method body, is going to look something like this, where we say try catch case a legal argument exception, because that's going to be what happens whenever we don't get a value UID. When we try parsing the UID from the string. So we'll say option UUID from string ID, and this expression will return either option UUID from string, the UUID form of the string, or nothing. And in the Java docs, we see that it throws an illegal argument exception. Okay. So it looks like it's returning it also for length reasons, but that would make sense because those are based on constraints of the UID. But okay, so coming back here to our domain, we're going to go ahead and use this, and we're going to map on the result of that expression. So we're going to go ahead and map. And I say map, we're going to match on it. So resolve ID. If we have the result ID, we can then actually execute an operation against the data store, air quotes data store. Else, we're going to just return nothing or none. So we're going to again pattern match. So in the instance that the resolved ID is some result ID, the UID, then we're going to go ahead and use that to then search for a recipe that has an ID. That may be that we pass in an ID that is a value ID, and then we still don't have a recipe because the recipe doesn't exist by that identifier. In the instance that the ID that was provided was not a valid UUID, then the case would be none, and then we would return back none. And then based on how this is used, what will happen in the route, in the instances none, we return not found. So, arrow keys are a little bit off. A little bit. Okay. So then from there, we're going to yield a response. So now let's see where we're at with our specs. So we wrote out some code. Let's see what it actually does based on our specs. See if things are working to specification. If not, we're going to iterate and then get things looking a little bit better. Okay. So our test passed, so that's good. So so in the specification on creation, we were able to use the identifier on creation to resolve the persisted, air quotes, persisted recipe. So that's good. So we have two scenarios. So for this video, what I'm going to do is introduce one or two more negative cases around retrieving recipes. And then from there, I think we'll end on a good note. And in subsequent videos, we'll switch out the data store. We're going to start adding out some more scenarios. We're going to start adding out more functionality. So the next feature we're going to add is recipe instructions, and then kind of just keep on building up the functionality and different things we can do as far as building web services in Scala with http4s. So let's work on our next scenario. So jumping back to the video, this video, we'll work on our next scenario. So we'll go ahead and say test retrieving non-existent recipes. So what I mean by that, or what the specifications mean, is that we're trying to retrieve a recipe that doesn't exist. So we have a valid UUID, but we don't really have we don't really have a matching recipe. So what we'll say is we'll have a UID, random UID, to give us a random UID. I'm going to toString that, and this will then return back a response that will not deserialize to recipe. So in terms of our specifications, we're going to expect that the API return a different state, and we're going to introduce a new model known as a recipe message here, and that we already started using that here. So we're going to, in this instance, return that recipe message. And then we'll use that recipe message to test against, to see that we got back a useful message in that, hey, the recipe ID that we used wasn't valid. So we would expect in our specification that our server respond with a not found. And so from here, based on this specification, so it's coming out that, but let's start with this specification right here, and then we'll build up. So we just want to say, hey, if we pass in an invalid UID, when we try getting a recipe, we should get back a 404. Let's see what happens. Okay, let's try that. So that's good. So that's working. Okay, so let's go ahead and then enhance our specification, and we're going to add a assertion that there's a recipe message that indicates the UUID or the ID provided wasn't valid. So what we'll say is assert IO. And then we're going to assert that we have a message equal to the following statement. Provided ID, or provided, or we could say something. Let's do this. Recipe did not exist with that ID. And then we'll say recipe ID, which is the ID we used to originally resolve. And then we're going to do some string interpolation, and then we're going to update our message to make a little bit more sense. Following ID identifier. Why not? So recipe didn't exist with the following identifier, so we would expect the recipe message to exist on return, or a format that is compatible with the definition of the recipe message model. So let's see what happens if we run this updated spec. So this fails. So let's see why. Empty JSON body. Well, wait a second. Let's see where we're at now. So looking in our production code, well, yeah, I'm not found. We don't return anything. So let's go ahead and update this code, and we're going to go back to our spec and design to spec, and we are going to go ahead and include a recipe message to satisfy this requirement. So we'll say recipe message with a message like this. Oh. Okay. Looks a little bit better, right? Maybe? There we go. Okay, so let's run that and see what happens. So on the sum case where we resolve the recipe, we return an an OK response with the resolved recipe. On a none case, we return back this message body with a JSON string with a message attribute equal to this expected value. So that it works. So driven by the tests, we've done some development with where we're returning a message indicating this negative case. So now let's add another case. In this case, it's going to require us to refactor the existing implementation. We're going to add a case where we're providing invalid identifier. So let's say test retrieving recipes with invalid identifiers. Okay, I can't spell first. I can't spell retrieving. So then for there, what we're gonna do is we're going to have let's copy this code real quick. We'll just do a little copy pasta. Copy pasta. So we're going to use the string 1 2 3 4, and that'll be our invalid recipe ID. And then from here, we're going to expect something a little bit different. So our assertion will be that the status will be a bad request because the ID was invalid. So there's an issue in the client side. And then we're going to update our assertion for our message to say that provided identifier was invalid. So now let's run this scenario and see what happens. Okay, so the assertion failed. So here we expected bad request, but we got back a 404 not found. So let's look at our code and see why. Well, this is why. Our none case is going to blanket return not found. So we need to enhance this code to be a little bit more smart in handling different cases. And so I think what we should do is we're going to change the method signature here from an option recipe to an either recipe message or recipe. We are going to take a little bit of a shortcut around handling these cases, I think, in like a really nice way. Like we could potentially have different recipe message types or have like a more general message object around like invalid, not found like states. But for the purpose of this video, we're going to use the recipe message value to drive the API response. So let's go ahead and update this signature, and we're going to kind of model it over the create. So now we'll have a little bit of consistency there. And we'll move the signature here. So let's go ahead and see now our method signature is updated. So let's go ahead and get this to kind of match what we're expecting. So if the ID was invalid, we are going to want to return based on our spec provided identifier was not valid. You see we have this logic here, so actually let's go ahead and copy that. So you see now it's failing because the type signatures changed. So we're going to update this, but let's fix the internal implementation first. So we're going to return left, well actually hold on, wrong copy pasta. So let's do let's match let's match on the resolved recipe. So we'll say resolved on the recipe. So if we got back a recipe, we want to return that, else we're going to return a left condition. So this is what I get for copy pasting code. So, and then on right, we will return the recipe. And then from there, we're going to return a left case. And let's actually make this a block to make this slightly more readable. Okay, and we're going to return our expected message. So let's go back to our spec, and we will say the provided identifier was invalid. And let's make sure our implementation matches that. So come back here, and we'll say provided identifier was not valid. And that's our left case. And then from there, what we'll do in our routes is we're going to handle that now. So this is going to be a little bit, this is where the shortcuts come into play, for the purposes of this video. We now have 3 potential states. So we have right, where we have a result recipe. And then we have two potential left states. So we would have a recipe message, where the recipe message we'll start with this string or start with this other string. So what we'll say, we'll do to ensure the appropriate response code is returned is we're going to do some filter here. Only matching this if this message matches the expected provided string. So we'll say if message starts with we're going to return not found, and then what we're going to do is we're going to actually return the recipe message. So we'll assign that to a value. So recipe message, and it's assigned using this @ symbol. So that is the recipe message here. And then from there we still have this other case to handle, where we got back another message, and it could be that it could be, right now we just know there's 3 conditions, but it could be that we have other ones, and it could be that we want to surface all those messages to the user. But for now, we're just going to kind of assume that there are these 3 states: right some recipe or right recipe, left recipe message, where the recipe messages that the recipe did not exist with the following identifier as a beginning string, or a left recipe message where the recipe message identifier was not valid. In production code, I would recommend doing something around like having distinct types, like message types around these different conditions, like I said earlier. But for the purpose of the video, we're going to do this, do this a little bit more simpler solution. So let's rerun our specifications and see where we're at now. Okay, so we've defined 4 specs around creating recipes, retrieving recipes, and some negative cases around receiving non-existent recipes and trying to receive recipes using invalid identifiers. I think this is going to be a good stopping point for this video. In subsequent videos, we will be swapping out the data store, but we will be reusing these specifications to make sure that the application is still functioning as expected, just with a new internal data store. We will be using Docker to provide Postgres for us, and then we will be writing out documentation around how other users of this project can utilize Docker to easily run these integration tests against the application server or test application server against a fully functioning database, allowing us to test our SQL and migrations, as well as our interactions between our service and our database. I will be providing the link to the video. Link to the video. I'll be providing the source code, GitLab in the video details, as far as other useful links. Please comment on the video if you have any questions or any feedback, and we'll go from there. Thank you so much. Bye.